Kia ora Year 12. In this video I'm going to do some more revision for algebra, and it's slightly harder than the first two videos. Probably still worth watching even if you're right at the start of your revision, but you'll need to make sure that you do plenty of practice on the basics from the Walker book or EP or Dr. Frost as well. So the first one I'm going to look at is solving an equation, and we can see in here that we've got a quadratic, right? We've got a quadratic because the highest power is an x squared. So when I'm solving a quadratic, I need to start by making it equal to 0. So I do that by subtracting 19x plus 14 from both sides. So we'll start off like this, and now my job is to factorise. Now you might be able to do this by guess and check, where you go straight into the brackets and you spot the numbers. It's got to be a 3x times an x, and there's got to be a plus and a minus. But I'm going to use this to give you some practice at the grouping method, which is where we somehow split up that middle term. So we want two numbers that times together to give me a times c, right, which is negative 42, and two numbers that add together to give me the middle number, which is b. So we want two numbers that have got a gap of 19, and we want them to times to give me 42, negative 42, right? So those two numbers will be 2 and 21. So we're going to make the 21 the negative number, because negative 21 plus 2 gives me negative 19, and negative 21 times 2 gives me negative 42. So what I need to do now is to break up that negative 19x using this. So we have 3x squared minus 21x plus 2x minus 14 equals 0, and we factorise in two steps. We get 3x times x minus 7 plus 2, factorising this little bit here, 2 times x minus 7 is equal to 0. So my first factor is x minus 7. So x minus 7 times 3x plus x minus 7 times 2 equals 0. So now we've factorised it and we need to solve it. Either x is equal to 7 or 3x plus 2 is equal to 0. So I'm saying either this is 0 or this is 0. This is why factorising quadratics works, right? Something times something is 0 means this one's 0 or this one's 0. So going really slowly with this one, because it's easy when you don't do that to muck it up. So we get two solutions, x is 7 or x is negative 2/3. Okay, what have we got next? Right, so we've got a fraction that needs to be simplified, and there's a quadratic in the numerator, and there's a quadratic in the denominator. So as soon as you see this, you should be looking at it to see how you can factorise. And the first thing to check is always whether I've got any common factors in my coefficients or my numbers. So my first step in here is to notice that there's a 4 common factor in the numerator, so it's 4 times x squared minus 9. And then here, this is a quadratic that we're going to have to factorise. So let's just park that for now and see what we can do with the numerator. So x squared minus 9 is a difference of two squares pattern, and you should be able to notice that by now. So we've got x plus 3 times x minus 3. And now we're going to have to get on with it and factorise this thing in the denominator. So let's just write that out. But if it's going to simplify, we kind of have a clue, right? We know that probably we're going to end up with one of those things in the numerator. Now, we won't always, but sometimes that's enough that we can do it by sight. But I want to do one more example of grouping in this video, so we're going to do it the slow way. So we'll just get rid of that mess from the last question. Right, so 4x squared minus 3x minus 27. So 4 times negative 27 is negative 108. And the middle number is negative 3. So I want those two numbers that have got a gap of negative 3 and times to negative 108. So if you know your tables well, it's going to be something to do with 9 and 12. 9 12s are 108. We want to have them adding to negative 3, so we'll make the 12 can be the negative of the two numbers. So that's how we're going to split up the negative 3x. Right, we've got 9 and negative 12. So we have 4x squared plus 9x minus 12x minus 27, or you could do it the other way around. They're both fine. And that equals, so doing this one first, we've got x into 4x plus 9 minus, and then we're doing this one, common factor here is going to be 3 times 4x plus 9, right? And so you should always be getting this one repeating. So factorizing it gives me 4x plus 9 times x minus 3. And now we're ready to keep on going on the fraction simplification. All right, so from down here, we're going to replace the denominator with that factorized version. So we've got 4 times x plus 3, x minus 3, divided by 4x plus 9 times x minus 3. And you can see now that we've got a common factor. The common factor is x minus 3, so we can divide through by that. That gives me my final answer of 4 times x plus 3 over 4x plus 9. And I can leave it like that, or I could expand out the numerator. It doesn't matter too much. Okay, so that's all the stuff I'm going to do in this video with factorizing quadratics. It is a skill that you really need to have a good grip on for level 2. So we've done quite a lot on that, but you need to make sure that it's fluent. Right, so let's have a look now at some of these other ones. I've put a few more in here about quadratics, but not ones where we've got to factorize. We're going to look a little bit at the idea of the discriminant now. So remember the discriminant, we write like this, and that's b squared minus 4ac. And the a, b, and c come from this expanded form of the quadratic. So usually we're trying to solve an equation like that. And the discriminant for this one, we're going to have a is 1, b is 2, and c is 1. So the discriminant here is b squared minus 4ac is equal to 4 minus 4 times 1 times 1, which is 0. So that means that if the discriminant is 0, this is where the graph of the parabola just touches the axis. So it means there's one root, the graph touches the x-axis. So for this particular one here, you can go back up here, x squared plus 2x plus 1, you can see factorizes into a perfect square, which is x plus 1 squared. So if you look at it like that, that fits with the idea of the discriminant being 0, because it's a parabola that just touches at -1. Okay, so that's that question answered. What does it mean for the graph? Well, it means that it just touches the x-axis and it's got one root. So the next skill I want to go over is completing the square. And I've put that in revision assignments 1 and 2 that are up on Google Classroom. Okay, so completing the square is not difficult and it's very useful. So completing the square means we're going to rewrite into this form. We look at that first bit and we say this is equal to x minus 6 squared. But x minus 6 squared does not give me exactly x squared minus 12x. It gives me x squared minus 12x plus 36. We don't want that extra 36, so we immediately undo it. We take it out. Okay, so that's how we rewrite that one into completing the square form. And just to finish that off, we get x minus 6 squared minus 19. And if we were doing some graphing work with this, that would tell me that the vertex of the parabola is at 6, -19. Okay, so somewhere way down here. Okay, so that's what it would look like. Right, the next question is another one to do with the discriminant. The graph of y equals x squared minus ax plus 9 has just got one real root. Right, so we're looking at this question here. What are the possible values of a? So one root means b squared minus 4ac is equal to 0. So here we've got a is 1, b is equal to negative a, and c is 9. So we've got negative a squared minus 4 times 1 times 9 equals 0. A squared equals 36. So a can be 6 or negative 6. Don't forget two solutions to that equation. Okay. Now the next couple of questions I'm going to do, and I think I am going to get through them, are 3 ones where we have to write as a single fraction. The key things to remember here are getting a common denominator and being really careful when you've got negative signs and expanding. So let's have a look at the basic idea here. We're not solving equations here, we're just simplifying. So we're going to get a common denominator, which is x minus 2 times x minus 3. So what do I have to do to x to have to this one here? Well, x minus 2 got multiplied by the x minus 3, so that's what I have to do to the x. Right, the x minus 3 here got multiplied by what to get the common denominator? Well, it got multiplied by x minus 2, so it's going to be plus 2 times x minus 2. Expanding that out gives me x squared minus 3x plus 2x minus 4 over x minus 2, x minus 3, which is x squared minus x minus 4 over x minus 2, x minus 3. And I think it would be fine to leave it like that, or you could expand out the denominator. So that's that one done. 3 minutes to do the next two. So the next one looks harder because it's got a and it's got x, but it's not really. Just think of a as a different number. Same idea. We've got to get a common denominator. So what's that common denominator going to be? Well, the common denominator is going to be x minus 2 times x plus 3. We have to multiply the a by x plus 3, and we have to multiply the 5 minus a by x minus 2. That gives me, expanding the top, ax plus 3a plus 5x here minus ax minus 10 plus 2a. Right, lots of terms in there because it's a quadratic, but not one with x in here. And we'll just copy that down. Okay, so some stuff disappears here. I've got ax, but I've got to take away ax. And I've got plus 3a plus 2a. So we need to collect up those like terms. We get 5a plus 5x minus ax. That'll do. I can't simplify that any further. So that's my final answer for that one there. Okay, one question left for you to try. Oh no, I have got time to do it. I'll do it very quickly. So let's get rid of all this. So this one's got b and x in it instead of a and x. Let's have a go at it. Okay, same thing again, common denominator. This time it's going to be b times x minus 2 minus b times x plus 3, giving me bx minus 2b minus bx minus 3b. Which gives me negative 5b over x plus 3 times x minus 2. There you go. That's all the algebra revision for today. I will make some more videos. If you've got questions, just send them in to me.